Alright, today what we're going to do is start a new unit on systems of equations. We're going to get into something a little bit different than just working with one equation, and it's called a system of equations. So previously what we were working on is one equation, one graph at a time, one slope, one intercept, things like that. So now we're going to get into something called a system of equations, and then we're going to solve those systems using different methods. The first method today is called substitution. So we're going to solve a system of equations by using substitution, and that's our goal. Having said that, we will still begin our lesson with prior knowledge. What are the things that we have to recall from previous lessons to be good at what we're doing? So the prior knowledge today, what we'll start with is knowing about ordered pairs. Obviously we have to remember an ordered pair works with x and then the y, so the x coordinate and then the y coordinate. We're also going to remember how substitution works, just substitution from what we've worked with before. And the way substitution works is if I have this example expression, 3a plus 4, what if a was some number? So what if a was negative 4? And then we have to remember how to substitute negative 4 for a, and then crunch that expression. So we substitute negative 4 for a, and then we were able to multiply now 3 times negative 4, which gives us negative 12, and then we can add negative 12 and 4 to give us negative 8. So that's a refresher course on something we'll need to remember. We also need to remember about solving equations, especially some complicated looking equations which we require simplifying first. So here's an example of a crazy looking equation that we'll have to recall solving for a variable. So if I had this and we want to solve this entire thing for just the variable y, we have all this messy stuff. We have to remember what it takes to get y by itself, to undo everything that's around it. And the first thing we have to do in this case is use the distributive property. We can distribute the 3 through the y plus 2. Everything else will remain the same. If we're not doing anything to the plus 3 or the entire right-hand side of the equal sign, there's no need to worry about that stuff. We're just distributing right here, and that's the first thing we're working on. So 3 times y and then 3 times positive 2, which would leave us with 3y plus 6. And then we have that plus 3. And then we have the other side of the equation. So to continue in the simplifying process, we can add 6 and 3, so we will do that next. And when we add 6 and 3, we get, of course, 9. And so we have 3y plus 9 equals 2y minus 7. And this is the part where sometimes we make mistakes. We have to remember, we've got to get the variables together on one side. So we have a 3y here, a 2y here. We have to undo one of them. I like to undo the smaller coefficient, so I will undo 2y. And the way I do that is by adding 2y to both sides. And so we have y plus 9 equals negative 7, and now we undo plus 9, and y is all by itself. So all of this process of solving equations, simplifying first, simplifying, getting the variables together on one side, undoing everything that's happening to the variable, that's going to be a key for the new unit on solving systems of equations. So let's talk about a system of equations. What exactly is it? A system of equations is a situation where you have more than one graph on the coordinate plane. Okay, so everything we've been talking about up till now has been working with one equation and one graph. Well, a system is when we have more than 1, 2, 3, 4, however many graphs that you have, but everything is working together on one coordinate plane. Okay, so remember that each graph that we have is represented by an equation, so a system of equations might look like this. Okay, so a system of equations might look like a situation where you have one equation for one graph, a different equation for a different graph on the same coordinate plane. And that is a system of equations. But we start the unit with solving a system of equations. So how in the world would we solve a situation where we have two graphs on one plane? What does that mean when we're solving a system? Well, the solution to a system of equations is simply where the two lines cross, or where the two graphs intersect. So the solution to a system of equations is an ordered pair. Remember, x comma y is an ordered pair where the graphs cross. Okay, so hopefully you can get a picture of what's happening. Remember, everything in math is a picture. This is what's going on. We have more than one graph on a plane. A solution to that system is where the two graphs would cross. So this unit is focused on solving a system of equations. And I've put together a few steps on solving a system of equations using a method called substitution. So when we're talking about systems of equations, there is a method that we could use to solve that system. The first thing we want to do is find the value of one of the variables. Most equations that we deal with have more than one variable, an x and a y. Okay, some equations just have an x, vertical lines. Some equations just have a y, horizontal lines. But most equations work with an x and a y. Okay, so we're going to find the value of one of those variables, either one. What we do is plug that value of the one variable into the other equation, and then we find the value of the other variable. Okay, so we're looking to isolate one variable in one equation, put that value into the other equation to find the other variable. Sounds complicated, but as long as you can remember that we list the answer as an ordered pair, you will see it becomes easier. So I'm going to start with a basic example. So let's start with a basic example of a system of equations, and then we'll solve it going through that process. So the first system that we'll work with looks like this. The two equations, we have 2x plus 4y equals 6, and we have y equals 3. Okay, so that's the first example of a system of equations. Remember, it's more than one equation working in a graph. So the first step that I talked about was find the value of one variable. Looking at these two equations, we have two variables. We have an x and a y. There is no x in this, but we still have a y. So through the whole system, we're still dealing with two variables, an x and a y. Do we know the value of either x or y? And the answer to that question is obviously yes, we know the value of y. This equation is telling us y equals 3. So we have answered the first step. The first step was to find the value of one of the variables, and we know what that is. The value is y equals 3. The second step was to plug that value for that variable into the other equation. So we got the value of y equals 3 from this equation. What we're going to do is plug that value in for y in this equation. So we're using both equations. So we're going to work with the other equation now. We have 2x plus 4y equals 6, but we know that y equals 3. So we're going to substitute that value for y. Not for y anymore. We know y is equal to 3. And that is what will equal 6. So that is the second step. Okay, so we have the first step was to find the value of one variable. The second step was to plug that value into the other equation. The third step now is to find the value of the other variable, which brings us into the prior knowledge piece of solving equations. Okay, so we're going to solve equations. Let's solve this equation for x. 2x stays 2x, and now we have a plus 4 times 3, which of course is plus 12, and then our equal 6 is there, and now we simply solve for x. We undo the plus 12 on both sides with a minus 12. So 2x equals negative 6, and then we undo times 2 with divided by 2 on both sides. And so we see that x equals negative 3. So we have now done step 3. We found the value of the other variable. The final step of solving systems of equations is listing the answer as an ordered pair. And remember, an ordered pair has an x value and a y value. And the two variables we know y equals 3, and we know x equals negative 3. So we know y equals 3, and we know x equals negative 3, but we need to list that as an ordered pair. Remembering that ordered pairs work, x comma y. So we can easily do that with x as negative 3 and y as positive 3. And this is the ordered pair on the coordinate plane where the two graphs intersect, where the two graphs cross, which is the solution to a system. So let's revisit what just happened. We have an equation or a system of equations here. First equation, second equation. Each of these represents a line. This is a line, this is a line. So now we have to find the value of the ordered pair where they cross. So where do they cross? We get one value by itself. We know that y equals 3. We're going to plug that value into the other equation for y and find out what x is. And then we list that answer as an ordered pair. And that is using substitution to solve a system of equations. So the process remains the same. Things get a little trickier. So let's see how some things can get a little trickier. So let's do another example with some crazier equations. So here's another system of equations. Here is the system of equations. Again, these are two different lines. They have two different pictures, and we're still working with two different variables. We're still working with an x and a y, x and y. Both equations still have two variables, x and y. So remember that the first step was to find the value of one of the variables. Now here's where things get a little abstract. Do we know the value of one of the variables? Not exactly. We don't know if a variable, what integer or what real number it represents. What we do know is that one of the variables is by itself. We do know what y equals. We know that y equals 2x. That's what we know. And if we found that value for y, we can use that value for y. Since we know that y equals 2x, we can still use that value, 2x, to substitute into the other equation. Here's where things get a little tricky. So now the second step is to take that value, plug it into the other equation. The other equation is 2x minus 3y equals 16. But we know that y is equal to 2x. So here we have the 2x from here, the minus sign from here, the 3 from here, but we're not going to use this y. We're going to change this y into 2x. See how that worked? Everything else remains the same. There is step 2 of solving using substitution. We have simply replaced this y with its equivalent value, 2x. Y is still 2x, we can still use 2x. Now we're ready to move on to step 3. In step 3, we begin to solve for x. So the first thing we have to do is simplify this crazy mess. This is all messy. We have to multiply by negative 3 times 2x. So 2x remains the same. However, minus 3 times 2x, minus 3 times 2x is minus 6x. And then the equals 16 is the same. And now we're ready to simplify that even further. 2x minus 6x is negative 4x. So we have negative 4x equals 16. And now we continue to solve for x. We would divide both sides by -4. So x equals -4. So now what we have done is found the value of x. We know now that x equals -4. So before, when we were talking about getting y by itself, we still did not know what number y was, but we knew it was 2 times x. Using that, we're able to find the exact number that x is. We know the x coordinate is -4. Now all we need to do is find the y coordinate. So here's what's going to happen. Now that we know this, we're going to continue on with this step 3 to find the exact value for y. We're going to plug this value for x into either of the original equations. We can plug this value for x into either of these original equations. So it would be easier to plug it into here, but let's show it the hard way. So continuing on, we're going to plug in that value to the other equation. So if we start with y equals 2x, that's the original equation we had. Y equals 2x, y equals 2x, but we know that x equals -4. We can substitute x for -4. And we can find out the exact value for y. So y would equal -8. So now we know an exact value for x, we know an exact value for y, now we know the ordered pair. So let's list it as an ordered pair. The x value is -4, the y value is -8, and there is the ordered pair where the two lines intersect. So that is how substitution works with crazier looking equations. Now before I finish, I want to do an even crazier example, because this stuff can get complicated. So let's do another example of another system where things get messy. If we have this equation, y equals 2x minus 1, and another equation, 2x plus 5y equals 7, we can find the solution. Where do those two lines cross? Okay, so in step 1, do we know the value of either variable? Do we know what x is, or do we know what y is? Looking at the top equation, we see that y is by itself. Y is 2x minus 1. We can use that information. We know what y is. Y is 2x minus 1. So we can take that information and use it in the other equation. So in step 2, we're going to substitute into the other equation. Now here's where things get really fun. So we have this other equation that we're dealing with. This is our y. However, y equals 2x minus 1. We're going to take that 2x minus 1 and put it in for y. Let's do that, and let's see what it looks like. So the 2x plus 5 stays there. However, y is 2x minus 1. Look at that crazy substitution piece. And remember, for the entire year, I've talked about using parentheses when substituting. Using parentheses when substituting. I've replaced this y with 2x minus 1. That's substitution. That's using equivalent values and replacing them. That's the fun part of thinking. And now we're ready for step 3. Step 3 is to solve the remaining equation for the other variable. So what we can do now is solve for x. So 2x stays 2x. What happens here? What happens here is the distributive property. Because now we have 5 times 2x minus 1. We have to use the distributive property. 5 times 2x is positive 10x. And then 5 times negative 1 is negative 5. And that's what equals 7. So we've used the distributive property. And now what we're ready to do is simplify some more. 2x plus 10x. I can add those. That gives me 12x. The minus 5 stayed there, we didn't touch it. The equal 7 stays there, we didn't touch that. And now we're ready to continue to solve for x. Just start undoing things around it. First thing we can undo is the minus 5. We can add 5 to both sides. And then lastly, we can divide both sides by 12. And then it gives us the result that x equals 1. So now that we have the value for x equals 1, we still need the exact value for y. So what we can do with this x equals 1, plug it back into one of the original equations and find out what y equals. So we take this x equals 1, plug it back into one of the original equations, and we can find out what y equals. So if I had the original equation, y equals 2x minus 1, but I know that x equals negative, or x equals 1, I can find out what y is. I'm substituting. It's so much fun. So y equals 2 minus 1. Y would then equal 1. So what do we know? We know x is 1. We know y is 1. Now we have our ordered pair. Remember, step 4, leave your answers as an ordered pair. The x value is 1. The y value is 1. That is where those two lines intersect. Okay, I'm going to do one more example. I'm going to do it a little bit faster to let you know that all these examples don't take forever. So in this last example, I have two equations. Y equals 6x minus 5 and y equals 4x plus 9. Step 1. Do I know the value of x or y? Yes, I do. I know that y equals 6x minus 5 because of the first equation. Step 2. I'm going to take that value for y and plug it into the other equation. The other equation is y equals 4x plus 9. But I'm going to take that value for y, substitute it into the second equation. Y is 6x minus 5. This is y. I'm going to substitute that. Now, remember to use parentheses for substitution. I've just substituted y's. So now, what's happening on the left-hand side with these parentheses? Nothing. So what I can do is get rid of them. And now I need to solve the equation for x. So again, that previous knowledge of solving equations. I'm going to undo 4x on both sides. I'm going to add 5 to both sides. And then I'm going to divide by 2 on both sides. So now I have my value for x. I know x is 7. So what I can do with that value, plug it back into an original equation and then solve for y. So my original equation, if I use y equals 4x plus 9, but I know that x equals 7, substitute the value for x. It's a lot of substitution. So the process doesn't have to take forever, unless you're switching colors for your pens like I am. So now we know, if x is 7, y is 37. Remember step 4, put that down as your ordered pair. X is 7, y is 37. There's my ordered pair. That's the ordered pair where the two original equations intersect. So it's some abstract thinking. It's the root of algebra, the ability to substitute equivalent values and use them. Just know what the equivalent values are. And you're able to solve a system by substitution. Thank you for your time. Good luck.